What's going on, guys? It's the Unhinged Engineer here, and today I want to make a video talking about 5 things I hate about aerospace engineering. Now, if you've been around the channel a while, you can probably predict that this hurts my heart a little bit. I obviously love aerospace engineering. I've talked about it a ton in previous videos, but I did make a video talking about 5 things I love in aerospace engineering, and while it is my dream job, it's not exactly perfect. So like any other field, I do have some gripes with it, and I thought it would be unfair to not share them with you. So yeah, today I'm going to talk about 5 things I hate about aerospace engineering. And so if you're considering a career in aerospace engineering, they're probably things worth knowing about. I will say I am ending each bullet point with what I'm calling a counter argument. While I do have all these complaints, I also want to say, like, this is why, in my experience, it's either not a big deal or it actually can be perceived as a good thing. First thing I want to talk about today is what I'm calling the passion tax here. And the idea is that aerospace engineering will force you to work harder for potentially less money than other fields. If you've ever seen big tech salaries, just as an example, there are people working at FANG companies that make a lot more money, especially in stock when you look at that side, a lot more money than aerospace engineers. You can even extrapolate that to other fields like finance, although finance has its own share of meat grinders. The point is, in my experience, aerospace engineering companies, especially the best ones, right? There are lots of freeloaders and large defense primes that kind of don't have to do a ton of work, but in the best aerospace companies that typically have the best pay, you're going to have to work for it, right? And this is most commonly known in companies like SpaceX that will work you like 80 hours a week for standard industry pay. So if you do the math, you're basically making half what you would otherwise make per hour. My counter argument to this is pretty straightforward. In my opinion, it's worth it. Aerospace engineering has a ton of the coolest problems, coolest applications. All these companies are doing amazing stuff. And to me, it's worth it because I'm compensated in a way through the passion and fulfillment I get from my work. So if I was working at like a large defense prime or a university research lab or a big tech company, I might make more money per hour, right? So less work for more pay, but I might not be interested in it as much. And one thing I have learned is that the hours start to feel a lot slower very quickly when it's something you just do not care about. So caring about the problems, really being challenged in a meaningful way, to me, that's a form of payment in itself. And that's why I think the passion tax, although pretty significant at times, is worth it. Next one I want to talk about is requirements. So I have a long history with aerospace requirements, having worked in a bunch of different environments that use this kind of systems engineering methodology. So requirements are effectively the benchmarks against which you have to design a system. So that could be interface requirements, that could be performance benchmarks, that could be test objectives, that could be schedule deadlines. Effectively, requirements are just the rules and regulations of what you need to do and what you need to satisfy in order for your program to be successful and the thing you're building to actually work in the way that it's intended to. Requirements in a lot of ways are a form of communication. It's a form of communication between different teams in terms of keeping track of what the design baseline is. Just as an example, it's important for the software team to know how much power they have access to, how much bandwidth they have access to. It's important for them to know these requirements that may come from other teams, right? So some kind of power or electrical team may tell them how much they can be supplied, or if they are supplied that amount of power, how much heat it might give off. Some kind of RF or communications team might tell them how much bandwidth they actually have access to and in what phases of a different mission. So all this is to say requirements are a form of communication, a lot of times culminating in hours-long PowerPoint presentations. I'm talking full days, preliminary design reviews, or critical design reviews, or anything else. I have sat in PowerPoint meetings all day before, 8 hours. And part of this is because it's the main point at which everybody agrees on a design baseline. And so you'll have someone who's primarily doing software or analysis or something else, listening to structural engineers or thermal engineers or communications engineers. Everybody gets a briefing from everybody else to make sure that there's no conflicts that we don't otherwise know about. Because for the most part, teams will kind of localize in their communication between clusters of who's most relevant to who. Sometimes things can break. Maybe thermal engineers didn't know the power requirements for a flight computer changed, or RF engineers thought they had more volume to put an antenna than structural engineers actually allotted for them, and so the antenna is going to be too big. All of this is to say the PowerPoints get very, very long very, very quickly. And the only thing longer and more monotonous in these PowerPoints are the tools you're using in between these big reviews. So at least with the PowerPoint presentations, you actually get to talk to people. But when you're not doing that, you're making Jira tickets, you're building out these giant Excel spreadsheets with a bunch of quantities and descriptions and test requirements and statuses and stuff like that. It just gets really, really old and cumbersome really fast. And nobody goes to engineering school to spend their entire day in an Excel spreadsheet. They just don't. So requirements can get pretty annoying pretty quickly. My counter argument to this really is we don't have any better ways to do this. Yes, more companies are embracing the move fast and break things, kind of constantly tinkering and iterating philosophy that tech companies have adopted. And I think it's working in a lot of ways. But the problem is the safety requirements and the performance requirements for a lot of things that aerospace engineers are building are just higher. You can't move fast and break things when you're designing an airliner with 200 souls on board. Or when you're designing a satellite, they're gonna have to put into space and operate for the next however many years, if not decades. Same thing goes for like Mars rovers. You can't exactly service that on the surface of Mars. It really is the best way we have, at least in my experience, to actually manage all these requirements and ensure that we're designing something to spec. So yes, while requirements are very annoying, they're necessary evil, and the sooner you wrap your head around that and embrace them, the better off you'll be. Inconsistent pacing. Now this is kind of a weird one because the reality is most engineering fields, like once you get out of college and you're not just doing homeworks on a weekly basis that some professor prescribed, things get really inconsistent in terms of timing really quickly. However, I have had the experience that aerospace is pretty bad in particular for this, and there's a few reasons why. For one, on the program side, programs range a lot from months to years, and then within those programs, there's different gates or testing deadlines that can vary on months or weeks. There's lots of different things that need to happen, usually in a very specific order, and that's not even accounting for stuff like procurement deadlines or contractor delays or stuff like that. There's just lots of variables in how aerospace engineering projects actually materialize. In addition to the kind of standard engineering variability you might see, there's also some specific ones for aerospace that are largely political. Events like a new president's getting elected, Congress passing or failing to pass certain budgets, or changing budget allocations in different parts of the world, or different types of technology. And then the big one, obviously, being conflicts throughout the world if you're working in defense, but even if you're not working in defense, it still matters. Political events in the world can actually affect aerospace engineering work in a more significant way because things are so complicated and coupled in aerospace engineering systems. And by virtue of a lot of the applications, on the defense side, it's pretty obvious. On the commercial side, if you're doing like commercial aviation, you're flying all around the world. Lots of things aerospace engineers do can be pretty significantly affected by politics. It's another thing that like no engineer goes, oh boy, I can't wait to get into engineering for all the politics associated with it. That's not exactly why we get into it, but it is a real thing that's worth noting. The counter argument here is really that organizations as they grow are gonna learn to get better at this. And so this is probably the harshest in some of the startups I've worked at. The smaller the team, the faster they're trying to move, and the more volatile their market segment actually is, the more jarring these changes are going to be. But as you expand to kind of larger and larger organizations, they learn to handle that and kind of insulate their engineers in a way from a lot of the effects world events might have on the business side. Thank your friendly neighborhood business development person, because this is something that they're dealing with on a constant basis. In fact, it's a big part of their job, right? Is predicting, understanding, and adapting to political changes, either in terms of customers, in terms of governments, in terms of geopolitical events. A lot of good organizations will figure out how to deal with this kind of thing, and they'll hopefully prevent their engineers from having to do it themselves, because engineers are not hired to do that. They're hired to write code or build stuff or drive impact on the technology side. So while this can get annoying, you get pretty used to it over time, and if you're working on an effective team, you'll all deal with it as a team. So not a huge deal. An unspecific degree. So I've mentioned several times that I find aerospace engineering to be a very generalist degree, but by virtue of being generalist, it's pretty unspecific. There are very few roles out there called aerospace engineer. Like, I studied aerospace engineering in college. I've never once had a job called aerospace engineer. Whereas if you study mechanical engineering or chemical engineering, it's pretty straightforward. You go become a mechanical engineer or a chemical engineer. An aero degree teaches you a little bit about a lot of things. And so, as I've said many times, It's up to you to figure out what you should specialize in. This becomes even more noticeable as your education gets more and more advanced, because you can't stay in la la land forever if you're going to go get a PhD. At a certain point on your journey to becoming a doctor of aerospace engineering, you need to specialize in something. And your degree will still say aerospace engineering. If you get a PhD in GNC or autonomy, you're going to have the same degree as somebody who did structural engineering or aerodynamics. It's all aerospace engineering, like under that umbrella, but you're going to have to specialize at some point as compared to other degrees where it's pretty straightforward. Obviously, other degrees have specialties in and of themselves, so I think kind of the floor is better because there are lots of jobs as a chemical engineer or mechanical or civil engineer. And so it's really just about which ones you want specifically. Whereas aerospace, you don't really have that fallback. There isn't a job of aerospace engineer. Some of this is natural and some of this has to be deliberate. It's kind of up to you to keep tabs on how well you're doing. If you feel like things are going in the right direction, or if you feel like you want to experiment with new stuff, it's all up to you to kind of figure out if you're getting where you're trying to go. And that's a large part of what I make videos about just in general. Counter argument to this is pretty much the same pro argument for aerospace being a generalist degree. You get exposed to a little bit of a lot of things. And if you have like a short attention span like I do, this is really, really fun. And that generality, that adaptability will continue with you into your industry career. And that can be really helpful as you get to more senior roles or want to pivot between different kinds of companies. It gets really, really useful to be a versatile engineer. Which, again, I'm not saying other engineers are not versatile, but aerospace kind of forces you to be in a way. So if that's something you're looking for, then this is definitely a great way to achieve it. So last thing I want to talk about here is that aerospace engineering is a very, very competitive field, both in academia and in industry. So when you're in school, first of all, it's very difficult to get into a lot of aerospace engineering programs, period. I'm surprised I got into one as good as I did. But even when you're in there, there's a pretty high attrition rate. Like I would say, when I started my aerospace education as a freshman, there were like 150 to 200 people in my major. And by the time I graduated, there was 75. So in the best case, that's a 50% dropout rate, at least in a large state school like the one I went to. In certain programs are a little bit more tailored towards individual students, lower student to professor ratios, those dropout rates can get better, but typically those degree programs are much more intense. Embry-Riddle being an example of a smaller school that is very prestigious and very well known in aerospace. But even once you graduate, the competition doesn't stop. Like a lot of these contracts that are being signed either with governments or with other organizations are competitive and have different deadlines and gates and down selects associated with those gates, right? So at certain points in large government programs, like the one I have demonstrated on the right, the CCA program run by the Air Force for the last few years, there will be certain checkpoints at which a bunch of companies will either test their systems and post performance figures or actually compete with one another directly. And then the government will select which companies they want to continue working with and by extension, continue funding. So aerospace attracts type A people for a reason. It can get very, very intense, both externally, right? So as you're dealing with these different forms of competition with other companies, it can get pretty fierce, but even internally, I'm not going to sugarcoat it. There's lots of type A, very intense people in aerospace companies. And at certain points in my career, I've been that person myself. So aerospace is definitely not a great field for somebody looking to chill out, at least in my experience. There are obviously companies that go against that stereotype, but the stereotype is there for a reason. It's true in a lot of cases. My counter argument to this is that if you want to roll with the best, that's the price you got to pay. In my experience, aerospace engineering is really, really kick-ass. The problems you're solving are kick-ass, and typically it attracts kick-ass people. And so if you want to roll with those people, if you want to work on the hardest problems, build the coolest stuff, you're going to learn to deal with it. You're just going to have to. It's survival of the fittest in that way. And I don't want to be too intense here. While I don't think somebody looking to just chill out is going to have a good time in a lot of these positions, I also don't want to make it sound like not anybody can do it. I really do think anybody, if they're passionate enough and they're willing to put in the work, can succeed in a lot of these areas of aerospace. So is it intimidating? Sure, it definitely can be, but I really think it's worth it for a lot of reasons I've even highlighted in this video that's supposed to be hating on it, but also other videos I've made before. I think the intensity is just kind of a natural byproduct of how meaningful, impactful, and pretty awesome the work you're doing is. So in conclusion, what are the 5 things I hate, quote unquote hate, about aerospace engineering? The first one is this passion tax I talked about. A lot of times you're expected to work more for the same or less money. And if you don't think that aerospace is cool enough to warrant that kind of tax, then you're going to get pretty burnt out pretty quickly and maybe switch to something less intense, which no shame. Next one is requirements, like having to track all these different requirements, review them in 8-hour PowerPoint presentations, do a bunch of administrative crap associated with them. Can get very, very annoying, but in a lot of ways it's a necessary evil for building complex systems that actually work how we want them to. Inconsistent pacing, so lots of factors outside of just the technical work you're doing, be it political, be it global, be it financial. There's lots of different factors that can affect how fast or slowly you have to actually do the work that you're being assigned. Preventing yourself from going into a tailspin is a skill that you have to learn over time. But once you do, and once your organization does, it gets pretty straightforward. Aerospace is a pretty unspecific degree, so the unforeseen downside of having a generalist role that teaches you a little bit about a lot of things is that it's less explicitly clear what you're actually trained to do. And so if you're not equipped to handle that uncertainty and drive yourself towards an actual niche, towards an actual subfield that you really want, things can get pretty challenging. And then the last point is that aerospace is pretty competitive, it's pretty intense, there will be lots of long days, there will be lots of sleepless nights, but if you really, really love it like I do, then it will definitely be worth it, and the intensity is only going to make your experience more fun and more worthwhile. So these are the 5 things I quote unquote hate about aerospace engineering, but as I've said about 19 times during this video, I really do love aerospace engineering, and if you're interested in it, I would highly recommend it. I would also highly recommend this channel because I make videos about aerospace engineering. I also make videos about professional development for engineers of all kinds. If you're looking to learn how to navigate your engineering career as a young professional like I am, definitely like, comment, subscribe. I'm the Unhinged Engineer. Thank you so much for watching, and I will see you next time.